Okay, before we get started, there's going to be a couple points when I ask you just pause the video, write down the problem that's on your paper, and give it a shot. But right now I'm going to work through all the problems so that you have something to compare it to. So I just ask that you don't just copy my work, that I want you to think through the problems as you go through it. Okay, so here's my thought process as I'm looking at this. And this has a squared term in there, so perhaps I have to use the Pythagorean identity, maybe not. And I also have got a cotangent in the denominator that I could rewrite in the numerator as tangent. Over here, I've just got one factor of cosecant x, and then I've got the secant x. If I'm thinking about which side is more complicated, I'm going to go with this side, the left-hand side. That's where I'm going to start. But I also see what they have in common, and that's a factor of cosecant x. That means that what they don't have in common have to be equal to one another. So in this case, it would not help me out to use a Pythagorean identity to expand that. I really just want to use the Pythagorean identity to go from two terms to one term. So in this case, it's going to help me out to rewrite that cotangent in the numerator and then see if something can cancel out. So let's get started. So my first step is to rewrite my cotangent x in the numerator by using its reciprocal of tangent. So that's the same thing as tangent times cosecant squared x. Now I know that tangent is the same thing as sine x over cosine x by your quotient property. I also know that cosecant squared x is the same thing as cosecant cosecant x times cosecant x, right? Well, this cosecant can be rewritten as 1 over sine of x. And from there I can see that those two factors of sine are going to cancel. So I've got 1 over cosine x times cosecant x. Keeping the end in mind, I now have that factor of cosecant x, so that must mean that these other two parts are equal, and they are, by using your reciprocal identity. So that's secant x times cosecant x is equal to that. And you don't have to flip those around when you write it. This is perfectly fine. Okay? Alright, so that's the first one. Now let's look at the second one. Tangent squared theta plus 6 is equal to secant squared theta plus 5. Alright, I'm going to give you a hint, and then I want you to pause it and think about it. How would it help you to rewrite that 6 as 1 plus 5? Okay, so pause, try the problem, and then come back. Alright, so if we rewrote the 6 as 1 plus 5, check out what happens. Got tangent squared theta plus 1 plus 5 is equal to this. Now I've got the 5's in common, don't I? That must mean that the part that they don't have in common, these two parts have to be equal. And they are because of the Pythagorean identity. It's really a two-step problem. So remember, since 1 plus tangent squared theta is equal to secant squared theta, then you can replace this with this. And that's exactly what I did. Okay? Alright, now let's look at number 6. Okay, again, I'm thinking to myself, I wonder what they have in common. Well, this is one expression. This is two expressions. This one has a degree of 3. This one has a degree of 2.